get our recording started right now. It says recording to the cloud. And I really appreciate everything that Colin does for us. And Colin, after this, if you can post the recording and any slides that we get from Nathan to our website and to YouTube, that would be great. Robert Powell was saying he might not make it tonight, so I know that that's one person who would like to hear you, Nathan, in recorded version. So that's good. And we're here to the waiting room again to admit again. It's just one of these things we have to do. Good. All right. So our format tonight will be Nathan from Aptera speaking during the first half. He'll speak for a while, and then we'll have Q&A with him. And the second half, we'd like to talk about projects and news. I honestly think there's been more news about EVs in the last month than any other month that I followed them, and I've followed them since I joined this club in 1994. So yeah, that's a lot of news in this last month. So we'll talk that up during the second half. So let me talk a little bit about Nathan from Aptera. That is amazing, the different things you have on your CV, Nathan. He's got a really good automotive background, but in the design pictures, there were boats and buses and planes and even a power propulsion module for the International Space Station. So Nathan, just for your info, I'm a retired NASA guy here in Houston. And so I noticed that right away. And just the wonderful designs that you've been able to work on and the experience that you have. I think we're really lucky to have you tonight. And I think Aptera is really lucky to have you so that they get the best possible vehicle on the road. And we'll see if some of our members end up being owners of Aptera. So Nathan, I'll turn it over to you, and I've put on multiple screen sharing so you can share anytime you like.
Oh, okay. Well, good evening, everybody. Thank you for having me. It's a real honor to be asked to come speak. To be honest, I didn't really have much prepared. I kind of figured, I would kind of like to put it to you guys to figure out what you want to talk about. I mean, we could talk about the Aptera kind of as it is now. We could talk about the story of Aptera, how it started 10 years ago. We could talk about other projects I've done kind of through the years. Kind of what do you want to talk about?
Well, I think Bill was talking about the decision of the three-wheel design and the 1,000-mile range. I believe one model's got that. Another model has the solar panels. So if you'd like to start with those parts of it, that would be great.
Sure thing. Well, okay, so if you want to get into the three-wheel aspect of why. So the story of Aptera goes back to about 2006, 2005, when we started working on the first one. And we had $3.5 million. That was our budget. That was our complete budget to build a car and launch it, right? So it was a different approach than I think other people get to do. And our desire to build the most efficient car possible was also playing into this, right? So how do you build this kind of dream vehicle for such little money? And the three-wheel thing came about, it was a cost-driven analysis, but it was also rolling resistance, right? So as you kind of get down this trade-off decision analysis on 3 wheels versus 4, you realize the lack of one more wheel, you lose a quarter of your rolling resistance, right? And of course, with an EV, that's a massive impact. So it was kind of a win-win all around, really. The only downside is potholes. You're guaranteed to hit every pothole on the road. But other than that, stability, I mean, as long as you get the stability correct, it's just the bar stool equation. They don't handle any worse than a 4-wheeled vehicle, and cheaper to make, cheaper to develop. It's a motorcycle, so we don't have to go through vehicle crash testing, cheaper on insurance, you know, et cetera, et cetera. So that was really the decision for 3 wheels, but the primary one was cost to develop and rolling resistance. And then the 1,000-mile range, well, that's an interesting one. So that came about So we do a lot of like vehicle analysis like before anything gets built, right? So the entire like multi-physics models and the MATLAB and all the stuff, we compile all this information. And when we were looking at the vehicle again this time around, so everybody knows the story. The vehicle first launched about 15 years ago. The outside story was that we couldn't raise the capital. The inside story was that we had a team from Detroit show up and they basically like decimated the program and sunk us financially and killed the whole program. So after the project
you had a what show up?
Team from Detroit. Team from Detroit.
Oh.
Yeah, so the board of directors hired a team of engineers from Detroit, and they came out and like turned the whole thing upside down and basically like kind of derailed the whole program to the point where we couldn't continue. So the program was closed down, I think it was about 2013, 14. All the IP was sold to an individual in California. Last year, that individual passed away, unfortunately, and the IP went back to the original founders, to Chris and Steve, and they relaunched the program. This time around, we've got much better simulation tools, much better batteries, much better controllers, much better options for motors. So when we started running the simulation on this new round of like EV technology, we realized this 1,000-mile range wasn't, it was achievable. Like it was ridiculous, right? Because you're like, there's no way, but you look at the efficiency of the vehicle and the packaging space we have for batteries, and the numbers just worked out that that was kind of feasible. So we're doing a 36 kilowatt hour pack, a 38 kilowatt hour pack and a 42 kilowatt hour pack. And they all fit under the seats and then behind the seats. So they're all center of mass is low and kind of centralized. And it's just working out to be incredible. Like the new batteries and the new controllers and the new motors are so efficient. It's really changing the game. Coefficient of drag was 0.09 CDA. So
0.09? I'm used to like 0.2 or something like that. You're less than 0.1?
Yeah, it was the same drag as the windshield wipers on a normal car.
Wow.
Yeah. So we're basically like displacing zero air, right? Even on the back of the car, how the airfoil comes down and tapers to where the tail light is, we're even venting the cabin air into that space just to fill in that last little tiny bubble behind the car. Like it's remarkably efficient. It's 2 passengers, but there's enough room in the back to sleep in. So it's nice and large on the back as well.
I liked what I saw on Electrek about a month ago. I looked over the Aptera website. I'm 6 feet 4 inches tall with a 40-inch sitting height. I have a lot of trouble with headroom and visibility out the top of the windshield, out the side windows. Does it give me 40 inches of headroom? What's the deck?
Yeah, it's actually a little tight right now. So the first one that we built, the one you see on the website, we're actually changing to give us a bit more headroom. So it is a little on the tight side. The first vehicle we built 10 years ago was fine. But the issue with the Aptera is because it's a kind of an egg shape in cross section. You don't have this kind of rectangle like a normal car. You have this where the belly comes in. So you have to kind of move the people up and out a little bit to get them to fit. So it's kind of a strange feeling inside the car. You're kind of sitting in the middle of the egg sort of a thing. It's a very strange kind of a feeling, but yeah, 6'4" is fine. 6'8" is going to be a stretch. We're doing it for like 95th percentile, so 6'4", 6'5".
Good to know. Yeah.
Yeah, you have to take your hat off.
You might, yes.
I just did the math at 0.09. That's 42 watts per mile. That's pretty incredible when you think about like the Bolt gets close to 250 watts per mile, and most of the Teslas get around 300 to 350 per mile. 42 watts per mile.
Yeah.
That is compared to what I've gotten used to seeing on the dash as well. Yeah.
Yeah. Well, the whole vehicle, I mean, we have to be less than 1,800 pounds to qualify as an autocycle, right? So 1,800 is max, 1,500 is target, right? So, I mean, you combine the lightweight with the aerodynamics and it changes the game, really. I mean, You know, like for us inside the program, you start working on this vehicle, then you look at other vehicles, and they all look obsolete. They all look so inefficiently heavy and just inefficient. You just can't believe that we kind of make cars the way that we do now. You know, and if there's any aircraft guys, and you know, NASA guys, you know, aerospace guys know, you know, aircraft monocoque is you know, it's the way to go, right? So, you know, it's and with composite materials now, like the cost of materials and the cost to build the cars isn't prohibitive. Like there's nothing really stopping us like doing this project. So it's you know, from an actual like real like logistics standpoint, like can we actually do this? And everything is available. Materials are available, batteries are available. We're using the Elafe wheel motors, which is a game changer from a packaging standpoint because now the drivetrain is in the wheels. The whole car is opened up for batteries and controllers and stuff. So that's a big change. We've got 3-wheel drive. It won't clip off one of the front wheel. You just skid down the road until you stop. It's the entire monocoque itself is so incredibly strong. When we tested the first car, we built this big fixture, and you have to compress the A-pillar to get the rollover strength crush test verified. And you need 1.5 times the vehicle weight on 6 inches compression to pass. We were at 4.5 times vehicle weight, and we still couldn't compress the 6 inches. So it was the highest recorded load ever on a vehicle. And when we took the hydraulic press off the body, the whole body that was caved in, like popped back out again. Like it went back to its original shape after it was crushed. So we're seeing that if you're in a significant accident with this vehicle, a rollover, and it gets squashed, it's just gonna like pop open again. So you're not stuck inside a steel, you know? So the composite materials are really like proving to be an incredible choice for doing a vehicle. And I don't think anybody's done, the Lotus Elise was the first composite monocoque vehicle. And then there's been a whole range of supercar vehicles that have done a composite monocoque with a front wheel subframe since then. But I think we're one of the first vehicles again to do a true composite monocoque vehicle structure, right? So again, more akin to an aircraft than a car, but it's very exciting to be part of this because we're changing the bar on what's safe, what's efficient, what's a good use of weight. We really think it's a bit of a game changer. So.
I've been looking at electric cars. I've been looking at the Tesla Model 3. Even though I'm a very big person, I want a low carbon footprint. So I'm telling myself I want the smallest electric vehicle that my wife and I could possibly get by with, you know. And then here comes the Aptera. It looks great in a lot of ways. I was thinking about safety in an accident because Tesla does as well as Volvo on their safety testing. But I told the meeting that we have every week, our Professional Aerospace Society, Dave's wife runs the meeting every week. I told that group I was really excited about this Aptera, and you're giving me some reassuring information about safety testing.
Oh yeah, no, it's remarkable actually how safe the monocoque is. I mean, it's akin to a Formula One monocoque, right? When you see them crush and they absorb the energy and they don't break, they just come together. And then the battery pack as well, of course, we're doing the same old thing where we're getting the cells and filling it with resin. So the whole battery pack becomes basically a structural moment as well, that gets bolted to the floor. So we're using everything we can to add to the structure and add to the safety, right? So the 40-mile solar range. Okay. So Chris, one of the founders of the company, has had a solar panel system set up in his garden now for 2 years, testing these panels. He's got it hooked up to a drivetrain, and he's just been testing it statically. So he's saying 48 to 52 miles a day in California, like on average, right? So that's kind of like more in the summer, less in the winter kind of thing, and you got to be parked obviously in the sun most of the day. But it was enough for them to say, okay, well that's significant enough to, you know, kind of get over this idea that solar panels don't actually give you any range, right? Like you look at the Fisker car that came out a couple of years back with a solar panel on the roof, and it was just a joke, right? And everyone, you do the math real quick, and you're like, well, it's like 36 days to charge the car or something. Whereas with the Aptera, because it is so efficient with the solar panels we had, we felt 50 miles was, you know, that's. I don't agree with that. It came out with this like never charge idea. I think that's pushing the idea a bit too far. I think the basic premise that we can put solar panels on without adding too much weight, we're not compromising anything on safety side. Long-term durability might be an issue. I don't know, like a hailstorm yet. We haven't figured out what happens in a hail if they get damaged, and if they do, then that composite panel is kind of ruined, right? So there's a bit of a liability there, but the upside is pretty significant. So,
is your vehicle, the usage case, is it kind of like a competitor to the smart car? Because that seems to be oriented towards just moving me and one other person from one place to another. and if like I want to go ride my mountain bike, like currently I put that in the back of I can take 2 bicycles in the back of my SUV. Like I would be then doing something very different. Right?
Yeah. I don't know. I mean, it's I don't know if there's any like direct competitors right now. It's really like it's kind of a showpiece, right? The Aptera. It's kind of like it's kind of like what you could do if you had no restrictions.
Yes.
There is like a series of vehicles following this that are planned that use the same super aerodynamic, super lightweight principles. But the Aptera in of itself was really just a study into how could you build the most efficient vehicle possible. That was really like the goal. And I don't really know, for use case wise, it's interesting. Like long road trips, I can see it being fantastic, right? Like city wise, I can see it being okay. Like it's not a small car, right? And it's kind of wide. So to get around a wide city is going to be interesting. But like it's just a normal commuter car, I guess is probably going to be the normal kind of use case, right?
Like if you're saying long road trip, like if I was driving out to California, then I'm probably going to want to take a bunch of stuff with me, which then, you know, people like that will be tough, right? So
it is quite big in the
commuting
back.
where I'm just taking my lunch, you know?
Yeah. No, like if you remember like the original Honda CR-V, like the original CRX, like from the 80s, or the hatchback one, there's actually a surprising amount of space in those things. And we're about the same on the Aptera, but we're about 3 feet longer. So in the back, there's actually like a significant like amount of space in the back. So I can see like Amazon using it for deliveries. I can see people using it for like food delivery, that kind of stuff. You know, if you live in a sunny climate, you've got basically 0 operating costs. So if you have a food delivery or a kind of a last mile delivery service, it could be really good as a fleet vehicle. So yeah, so we have 2 and 3 hub motor versions. We have just front wheel drive, or we have 3-wheel drive.
Okay, so you do have both, yeah.
Yeah.
So yeah, folks, keep putting things in the chat because that makes it easy for Nathan to see.
Yeah.
So Nathan, I have a question about what about frontal crash testing and other crash testing? Since you're an auto cycle, is there a standard for doing that kind of testing, or are you all developing your crash test program to figure out, you know, how the vehicle does in a rear end and a front end collision, a side collision, other than rollover?
Oh yeah, no, we're using regular 4-wheel passenger vehicle FMVSS specs for the crash for the baseline. So we're hoping to exceed every regular passenger car spec. The only difficulty for a small company is airbags. So still today, the only company we could use to work with was Takata. We're the only one who had actually engaged with a small company. And of course, those guys were the ones that had the big recall problem. We're basically down to using seatbelt airbags at this point. So they're an invention that came out where the seatbelt itself has the airbag, and when you hit something, it inflates. We can put those in the vehicle right now, and that's probably what the first run is going to have. But the monocoque itself, like I said, like as far as like impact, it's going to be one of the safest vehicles on the road because it absorbs the energy so well. Right, the whole cabin is a monocoque structure that bonds together and leaves a cavity within the whole thing, which we inject with foam afterwards. We inject a special 3M foam into that cavity, and it's so incredibly strong you wouldn't believe it. Like it's like we try to break these things and you just can't break them. And when they impact, they absorb and they flex and they pop right back out. So and it's just regular fiberglass with a hex core and epoxy resin. Like it's really nothing amazing on the material science. It's just how we're designing the monocoque and how we're designing the stress paths and stuff. So
if you're light enough, then if you get hit by a heavier vehicle and the monocoque does not collapse, it's gonna be like throwing a ping pong ball out in front of a bus. You're just gonna bounce off of it.
Yeah, basically on the very first car we did, we actually had the battery pack in the front subframe, and we had it designed to shear. So we had the bulkhead on 45 degrees, and we had it on impact where the subframe would go down with the battery and the car would go up, and they would actually kind of separate, so that the energy of the heavier the mass can move independently of the light mass of the body. But we didn't do that on this one. There was a bit of a liability around that happening at the wrong time, so we didn't do that. So but yeah, no, I mean, from an impact standpoint, you would literally bounce off things, and yeah, it would be like being inside an egg, right? So I mean, you wouldn't really yeah, we haven't really crashed one up yet, like in a really like severe like 2-vehicle impact, but it's going to be interesting when we do get to see how the physics of such a light vehicle impact with the physics of a heavy vehicle, like a normal vehicle. So.
Well, I think the important thing is that you're going to be using the standards already set for four-wheel automobiles, even though you don't have to certify to that because it's an auto cycle. You're going to be testing to that, and that's reassuring for me.
Yeah, and then on the safety side too, of course, with the 3-wheel motors, we've got incredible torque vectoring possibilities, and we're even using the because you've got the torque directly applied to the wheel independently on the front, you can simulate a power steering system. So just by vectoring between the two, you can get the wheels to turn. So we're even using the vectoring to basically eliminate the power steering system. But on the safety side, it's incredible, the reaction time on these motors and what we can do to catch the vehicle on the skid. Control it, like the ABS and the system is just going to be incredible on this thing. And electronic drive is like, no one's really discovered yet where the limits are with these hub motors, right? Like this is like a brand new thing. Alafe just released these things. I think there's 1 or 2 other people using them, but we're one of the first ones to actually try these things. And the physics of putting the weight in the wheel on a lightweight vehicle is going to change the dynamics again. And we're not exactly sure what we're going to see when we actually get this thing on the skid pad and the skid pad kind of thing. But it's going to be really interesting to see how a hub wheel motor vehicle that's so lightweight actually handles. So it's a bit of an experiment still in that respect.
And you talk about what the handling will be when it comes out. So I see the question there. What is the production timeline?
Well, we've already started. So we're tooling up now for production. We're through the final kind of changes on the engineering side. We've got suppliers lined up, and we're turning on the tap in the next 2 or 3 weeks to start building the pre-production range. And then they go into testing, and then we get into qualification, then we get into certification, and then by the summer or late summer kind of thing, we should be cranking these things out as fast as we can. Yeah. And yes, acceleration is pretty decent. Yeah, I think 0 to 60 in like 5-point-something seconds.
Nathan, what have y'all come up with? What kind of rate the charge rate will be, and will it have high-speed DC charging capability, and what will that rate be? Have y'all determined that yet?
Yeah. Okay, so we are looking to get an onboard charger. We have a couple of options. I think the Delta Q actually was one of the better ones. One of the crazy things that Chris and Steve are saying is that because it's so efficient, if you plug into a regular 110 outlet, I think they're saying you'll get like 50 or 60 miles of charge in an evening, like overnight kind of thing. So we're kind of back to plugging into the 110 outlet again, which is interesting. But of course you can do the, we're actually using the Tesla charge plug on the back. You guys probably all saw that. So we're kind of set up to use the Tesla system at the minute. But that's obviously going to have to change before we start building the cars unless we have the permission to participate in that, which I believe is, I'm not sure where that discussion's at, but I know it was started a few months ago. But yeah, it's going to be your standard fast charge, but because it's such a small battery pack, I mean, it's a 36 kilowatt hour battery pack in the one that I'm going to get. You know, it's a fairly quick charge anyway. And I think one of the other claims is because the car is so efficient, if you stop for 20 minutes for a quick charge, your actual range is much higher than a regular car, right? So because the efficiency is so great that the amount of energy you get in a 20-minute stop is going to get you further, regardless of what kind of charger we use. So in that respect, it should be really good, right? But it's okay. But again, on the charging side, there's all of a sudden like 10,000 options. Like it's incredible. Like being in the on the supply side of the EV industry right now, we're seeing every single tier 1, tier 2, tier 3 guy trying to get into the game. And they're all trying to come out with drivetrains and motors and controllers or anything to try and get into this EV game now. So all of a sudden, there's like an incredible option for all this stuff. Like it wasn't like this a year or 2 years ago. And they all want to work with kind of these size companies now, which is also remarkable, right? This was not the case a couple of years ago. So we've got a gluttony of controllers and chargers and DC-DCs and all this kind of stuff. I mean, there's all of a sudden all these options, which is fantastic. Big guys, small guys, right? And so I think we'll get the best of what we can get with the budget that we have and the volumes we're talking about, because that's obviously the driver. But we should have some of the best technology out there as far as all of the drivetrain kind of thing. And then the other thing we're looking at too is we're really big into the whole right to repair thing, right? Like we truly believe these cars should last an indefinite amount of time. They should be repairable by anybody who wants to work on them. They're very simple. So, you know, I mean, we're almost making it hackable. We're almost making it so if you wanted to change your controllers or you wanted to change your DC-DC, you can literally just get in there and do it yourself, right? Like the homebrew EV systems are getting so good now that really that works for a production vehicle, right? Like if you go to EV West and you get your regular kind of like conversion kit, if you're only building 500 vehicles or 1,000 vehicles, you could almost just use that stuff, right? And we all know how simple that system is. You get your motor, controller, battery, throttle, that's your entire system. So we don't see it having to be any more complicated than that. And the controllers now are getting so good. They're doing everything we want from the traction side, from the EPS side, all the regen stuff. We're using a controller from a company called Accelerated Systems here in Canada. And they're claiming you can actually eliminate hydraulic brakes now. Like they can take care of that. Like we don't even need brakes anymore. So we're really pushing for this whole thing to kind of be hackable, right? Like you own an Aptera and 2 years later a charger comes out, you know, just swap it out, right? I mean, it's going to be very simple. It's going to be accessible. You know?
So when you say no hydraulic brakes, you're saying that the motor can be controlled not only for regen, but to stop even when you need a quick stop all the way down to zero.
They're saying you can. Yeah.
Cars that are in production on the road now still use the friction brakes for the last portion of stopping.
That's supposed to stop it. Yeah. Yeah. No, they
claim
you can. Yeah.
Wow. So it's advanced so far that you could use it to stop even when you've got that panic type stop or get all the way down to zero. Okay.
And
good.
They're so confident in the reliability of the system that you know, they would actually like to say that. I mean, that's people's lives. You know, you don't say something like that flippantly. That's a serious statement. So the fact that they're claiming that now is like, you know, we want to try that. We want to build an e-bike and just get rid of the brakes and see if it works. I mean, that's a remarkable claim, and that would save 200-300 pounds on the vehicle weight, and you know, $1,000 off the retail price. So, you know, that's a big deal.
And another system to maintain. I mean, of course, the car service industry at dealers and so forth are already crying about going to EVs, and this is just one more system to take out of the need of being serviced. Wow.
Yeah. And then again, like I said, with the in-wheel motors, we can also eliminate the power steering system, right? So it's lightness begets lightness, and simplicity begets simplicity. It just keeps going that direction.
So see some more in the chat there. What is the power and weight of the hub motors?
The S400 and the S700 are the two versions. And I believe the 400 is 4 kilowatt and 700 is 7 kilowatt. So it's 4 kilowatt per wheel, which is decent. I think like I say, the acceleration is sub 5 seconds, and then top speed I think is around 100 miles an hour.
I think it's 40 kilowatts and 70 kilowatts, isn't it?
Is it 40? Did I say 4? Yeah, 40.
Yeah. 40 and 70.
70, yeah.
I don't know if we caught it. Which charging plug? I'm going back in the chat, trying to be sure we caught questions. Using the standard J1772 and the DC charging plug pins underneath? Or?
No, the guys didn't like the 1772, so we actually used the Tesla Model 3 plug, right? So we went and got a Model 3 charging plug and adapted it to the car kind of thing. So like I said, I don't think that's gonna. I think the goal is to try and get them to. I don't know what's gonna happen. We'll probably end up changing to the 1772, but we don't really like that plug. It's kind of not. It's not great to use. It's not as good as the Tesla plug. Right? It's not as good as
some of us would really, yeah. I mean, for simplicity, using the main power pins for both AC and DC, as opposed to having jerry-rigged a couple of DC pins underneath the J1772, as it was. A number of people would say, yeah, it'd be much more elegant to go in that direction, whereas all the other manufacturers adopt the SAE standard. But going along that train of thought, if you're going to use the Tesla connector, would you also buy into the Tesla supercharger network?
Well, that's a bit above my pay grade, that question. I mean, it's that's obviously a very well protected network. I mean, they haven't opened up to anybody else yet, right? So, I mean, it would have to be a pretty sweet deal for us to get in on the network, but it'd be really nice if we could. I mean, I don't think.
You're taking a niche that Tesla hasn't announced that they're going to tackle. I mean, if it was the other end of the spectrum with semi-trucks, that would be maybe competing with them. But I think there was an article a month or two ago about, again, Tesla considering bringing someone else in to be able to use their network, because that had been announced many years ago. And then, of course, nothing has come about. But it was mentioned again a month or two ago by Elon that he was talking to somebody. So just trying to put the pieces together, maybe figure out if that somebody who said was talking to him about using the supercharger network was Aptera.
I can't say. And honestly, I don't know. It might be, but I don't know. I hope it is, because I mean, it'd be fantastic, right? It'd be a really, really good.
Yeah, and I think one of the problems with other cars would be if they were to charge very slowly, then they would take up stalls at Tesla superchargers for long periods of time, which would be to the disadvantage of current Tesla owners. Whereas with the smaller size battery and being very efficient so that you can drive a long way on the smaller size battery, Aptera vehicles wouldn't be sitting in a stall for appreciable amounts of time. So it would seem like an ideal partner to bring in to use the network.
Although I just caught this Biden's announcement of, was it 550,000 new charge stations he wants to install? You guys must be following that one. Yeah.
Some big number. I mean, it's constantly expanding. I mean, you hear different numbers all the time.
Like, do you feel that that's a reality? Like, that's actually going to happen? Because that's your normal standard open charging network, right? That's your normal 7072 chargers, right? That's what he's proposing. Like
what Elon is proposing?
No, Biden, the new, yeah.
Oh, I didn't catch which one you said. I don't know. So anybody else know?
It's high speed DC network. It's going to be a high speed charging network across the country. So
okay.
And there may be in that number, there may be also L2 stations, but the idea is to get high-speed charging capability across the country so that vehicles can go cross country, to take that take that off the table. Although that's already been happening by Electrify America and EVgo to some extent, but there are gaps in those networks that they want to complete, and that's what that map was. They just put out a map that showed a completeness of the network.
Okay. Going back up in the chat again here, Nathan, I don't remember if you caught this one. If one were to clip off one of the front wheels in a crash, can it be replaced?
So the front suspension is held on a metal subframe, which is attached to the body with rubber isolators. If you were to shear a wheel and you bent the subframe, then you could just change that whole subframe out. So as long as the central monocoque doesn't get damaged, it's kind of like a motorcycle helmet. Once you crack it, you kind of throw it away. But as long as you don't damage the primary structure, then everything else is replaceable. Same on the front, the rear swing arm is held on a small subframe with isolators. That hooker will be replaced as well.
Okay, so yeah, it sounds like things would be repairable for that. Okay. AC and heating, the next question I don't remember hearing a response on.
Yeah, no, that's a challenge, of course, for everybody in the electric vehicle world, right? Especially in cold climates. We have a bit of an advantage that the composite monocoque, but because it is a foam-filled plastic structure, the insulated qualities are really good. Like if we had double pane glass, it would be like something. So we don't need as much heat and cool as a normal car, but it's still a challenge, right? Obviously, it's a big hit on the range, huge energy usage. So we have been experimenting with heated and cooled seats, which theoretically is more effective than blowing air at your face, right? Like they find, but personally, I don't really buy into that. Like, you know, it doesn't feel as effective, but it's much more efficient to do heat and cool seats from an energy standpoint. And then there's a few suppliers we're talking to. We've got like a regular HVAC. There's a few suppliers now, tier 1 people doing HVAC systems for EVs specifically. So they're a little more energy efficient, and they don't require vacuum, and they don't require that kind of stuff. So we got one of those in there right now. We would love to do a heat pump. You know, we'd love to get our hands on some of that kind of technology. We are using radiative skin cooling for the HVAC on the belly pan. So that's another trick from the aircraft industry. We've actually got a couple of tubes laminated into the belly pan on the backside, so that the skin surface actually cools the condenser for the HVAC. But yeah, otherwise it's kind of just normal stuff at this point. You know, but like the heat pump would be the way to go, obviously. But that's big bucks, and that's probably next year for us.
Yes, we've heard about heat pumps going into other vehicles to make them more efficient.
Yeah.
So there's a comment here. Any comments on acceptance of Polaris Slingshot as motorcycle in states and acceptance of Aptera?
Yeah, like market acceptance, you mean? Like just for a 3-wheel in general?
Well, it could be marketing, or whether it's under safety, under the state Department of Transportation or something, whether they would allow it to be considered a motorcycle.
Right, a couple states when the Slingshot came out actually wouldn't allow the sale of it for a while because it had a seat instead of a saddle. Like some of the 3-wheeled, the reverse trikes had saddles, so they allowed it because it was more of a motorcycle. But they finally overcame a lot of those battles, and you know, you've seen Slingshots now on the road for a couple of years, and you know, it's by a major manufacturer. So I just, you know, was wondering any thoughts on how that's going to, you know, help the acceptance of Aptera.
So it's probably, okay, so you've also got Electromechanica and you've got Archimoto. And Electromechanica have also been doing a bunch of work to try and get this autocycle classification legalized in all states. And I believe you're right. I believe now they're road legal in every state. I don't know, as far as acceptance, I don't know. I mean, 3 wheels are always going to be a niche market, right? You're not going to get into the mainstream with 3 wheels. I don't know, like this is such a weird vehicle, right? Like the Razor is a sports car, right? What's the other one? The Slingshot is also like is obviously a sports car. I don't know. I don't know if having three wheels, if you're really into aerodynamics and efficiency and like EV technology, if having three wheels would be a turnoff, right? And I suppose that'd be a question for you guys. You know, is that a you know, is that an absolute like no way? I would never do a three-wheel vehicle, or do you think that like would you guys accept a three-wheel vehicle if it was this well engineered and this like much of a game changer? I mean,
I would.
I think I would too. Yeah.
Yeah, same here. I mean, I'm really just super excited to see Aptera come back.
Yeah.
Yeah,
Yeah, we are too.
the climate crisis is as big as the pandemic crisis and other crises that we have. I'm looking to everybody to make a change as radical as this, you know, because of that reason. Maybe my wife and I can buy a Tesla Model Y for an SUV, and then if we still need a second car, maybe this could be it. You know, it's crisis time. It's radical time. It's time to wake up.
Yeah, yeah, and we have the technology to do it. We have the materials, we have the engineering science, we have the right know-how. Like there's nothing magic about the Aptera. It's just an aircraft, essentially, aircraft technology applied to vehicles. Like there's no reason everybody couldn't do this, right? There's no reason cars have to weigh 3,500, 4,000 pounds, right? Like it's absolutely absurd, right? You look at Lotus and you add lightness and add simplicity, and you know you look down that ethos. Once you start making things simpler and lighter, other things get simpler and lighter, and it cascades that direction. Versus you make something heavier, and then it cascades in the other direction, which is what everyone else has done, right? So I just saw today that Continental had to make new tires now for EVs because they're getting so heavy. Right? I think the new Porsche was like 6,200 pounds or something. Right? I mean, this is insanity. That's crazy, right? Like. It doesn't make any sense. Like, why would you use that many batteries to move one vehicle around, right? Like, it just doesn't make any sense. And we're all seeing the lithium mining issues now, and we're all seeing like just getting battery cells is going to be harder and harder all the time. Right? I mean, Tesla came out the other day and said the reason their semi-truck isn't on the market is because they just don't have enough cells to power the thing, right? So we're going to have to do more with the cells that we have, right? Like you say, it's going to come down to getting a bit more thinking outside the box now, right? So. You know,
so looking at again some of the older questions in the chat, is the 40-mile solar range tested or theory? To do like 40 miles from that.
Tested statically. So it's like I said, Chris in his backyard, his house has had it set up with the drivetrain running on a simulation now for 2 years. So that's what the numbers he was getting from California. So. Okay.
And who manufactures the solar panels? Question in chat.
Is it SunPower? It's the regular like square, like 4-inch square cells that you just buy the wafer stack, and I think they're SunPower. Again, nothing's right, like cheap. Like the only breakthrough there is now they're more flexible than they were a couple of years ago. So a couple of years back, you flex them just a little tiny bit and they would snap. Now you can get a fairly decent amount of curve out of them. So we can put them in the mold when we lay the composites up, and they actually conform to the surface and actually sort of work, right? Like, I mean, we've had a few experimental cars that were built and tested, and they seem to be working okay. We're not getting too much. There was a concern about the resin blocking too much of the UV, so we weren't getting very good performance from the solar panels once they were actually encased in the composite. But that's not the case either. The resin is actually fairly UV transmissive, so we're not getting too much detrimental effect on the solar panel from the resin. We've got UV inhibitors in the resin, so over time they shouldn't yellow and cause any loss of performance over time. So, yeah, it was just one of those things, right? I mean, it's a couple $100 on solar panels and some wires, so why wouldn't we do it? You know?
Right. I don't remember if you caught this question. Is production in California?
Yes.
Yes. Okay.
Yeah, down in San Diego, the main plant.
So, Eden, I want to put my comment here. I'm also another engineer in the group, chemical, but nevertheless, I've been dabbling with the solar and EVs, and I'm in the market for maybe a Model 3. I think that concept is brilliant because we engineers love simplicity and value engineering. Remove the things that are unnecessary and use the ones you have to do what you need. and really have a cascading effect. So I love it, and I think that's really a very good market. The thing that concerns me, of course, about the American market, Americans and also many people in the world, they like their SUV. They like to carry a whole family and all the luggage to go around the world, right? Of course, COVID has really crimped that a little bit. So I think it will probably market very well as a commuter car in the city, where you don't need to carry a lot of stuff. But I think it may not be well adopted for a family car yet. You know, eventually might be.
Yeah, yeah.
But thank you for presenting. That's excellent.
No, thank you. No, I mean it's great to get some feedback and actually be able to kind of say this kind of stuff out loud to a group who like really understands EVs from a technical standpoint, right? I mean, you guys have all dabbled. I mean, I came from the EV world. My background actually with electric vehicles was making show cars for the OEMs back in the 90s. And we would build these concept cars that they only had to get up on stage and then leave the stage. That's all they had to do. And we put all this effort into making the gas engine work and radiators and then we came across an EV website and we bought one of the first early kits and we just put it in one of these show cars. So you just had to get up on the stage and that's it. And we're like, oh, that was great. So we started doing this on all of the show cars that just had to do these little drive-throughs. We just made them electric. And that's where it all started. It was like, this is super easy. So we just kept going with that. Then we actually got to know AC Propulsion. So Alan Coccone's group down in California. And the Alan Coccone's group came out of the EV1 program. So the GM EV1, AC Propulsion developed the drivetrain for that. When EV1 closed down, they kept going, right? So we met these guys. They were in San Dimas. They had the motor and controller. It was $40,000 for the motor and controller unit. But it was the best on the market. And we built a car called the Volvo 3CC. And if you guys do a quick Google search on that one, it was a very interesting car because it was AC Propulsion had built they built a race car from England called the T0, and they put lithium batteries in it. And Toyota had done a car with lithium batteries before this, but I think this was the first one to use the 18650 cells, right? I think AC Propulsion actually kind of came up with that idea. We were hired by Volvo to build the 3CC concept, and the design director of Volvo was big into EVs. He knew Alan Coccone, and there was a few other folks involved kind of around AC Propulsion. And they said, okay, we want to build a car to highlight this technology. We want to build a car to show this AC Propulsion drivetrain and this 18650 cell configuration. So AC Propulsion came up with the laser cut plate that sandwiches the cells into the bricks. I designed the battery housing, and then we manufactured the battery cell, and we built the car and shipped it off to Volvo. And Volvo at the time weren't interested in EVs, so it didn't go anywhere within Volvo. But the company I worked for, the next project they took on was the Tesla Roadster. And the Tesla, well, what do we have to put in the Tesla Roadster? And they said, well, we just did this Volvo, and we have all these batteries in this drivetrain. We put that in the Roadster for you. So the whole Tesla battery technology with the 18650 cells and the plates all came from AC Propulsion and the Volvo 3CC program, and then the Tesla Roadster. And then Tesla went with it, and of course they are now who they are now. But it was a great origin story around kind of how that whole thing came together. And I love the connection to the EV1 program, right? Because the EV1 was phenomenal, and people have forgotten about it, right? I think there's one or two left in the world that people have saved. But it all came from that program. Like that was the originator of all of this stuff we're seeing today. Goes back to that point in time. So like it's a neat progression, and it's neat to see. I love how today it's come to the simplicity of the controller and the motor and the batteries, and how everything's consolidated, and the controllers are becoming more and more consolidated. And if you actually look in the RC world, so I dabble in RC cars a lot, because I think that's actually the forefront in EV technology is radio control cars, because those guys have such a small scale, they can do crazy things. The new motors have the controllers right on the back. And that's the whole unit. It's literally just a motor, and you plug the battery in, and that's your whole drivetrain. So I'm seeing now, we just tested a controller for a bike last year, where the controller was on the back of the motor. And we're just a step away from seeing that integrated now. So it's literally just going to be a motor with a controller that you hook your battery wires into, and your throttle and whatever inputs you want. But it's going to become that simple. And the AC propulsion system, when we bought the first one from them, their guarantee was that if you put their motor in the desert with solar panels, it would run for 10,000 years. So they had a 10,000-year warranty on their motor. So it's just lovely stuff, right? It's just fantastic stuff.
Yeah.
Can I just interrupt for just a second, Dave? So I've seen Kelly Motors, Kelly Controllers actually already has a built-in plug-in set for a QS motor built set where you can actually just plug straight power into it and a 5-volt, a ground, and a signal for throttle. They've already got it.
No way. Oh, I gotta check that out.
Yeah,
that's fantastic.
You'll have to check it out.
And how long is that going to last for? I mean, what's the warranty is probably 5 or 10 years, but I mean, if you don't blow it up and you don't short circuit the thing, it's probably just going to last indefinitely.
Yeah, but it's a Kelly controller, so I rated about 50% of what it should be, and then I'll also rate the motor at about 50% of what it should be. So take that with a grain of salt.
Yeah, the Kellys are pretty interesting. They got a good history, but the last one we got here was made in China, so I think they're making those in China now. But the ASI controllers, the accelerated systems out of Canada here, they're worth checking out.
Yes,
they've got a fantastic. Yeah, they're really
except for the fact that they won't do a controller over 96 volts.
I know. So
I have 2 electric projects that I built at 144 volts, and Kelly was the only one that could do it.
Yeah. That's a shame. That. Yeah.
So seeing the question here, how will service be handled?
We're kind of taking the Tesla approach where, service comes to you kind of thing. But we're also really pressing this idea that fix it yourself kind of an idea, right? Like, if anybody's familiar with like the new generation of like service technologies for like service technicians in a dealership now, there's literally like videos, and it's like an interactive video, and it's like, take out these bolts, and it shows a wrench, and it shows which direction to turn the wrench, and it shows, what I mean? And then put this in. So, and the new generation, you actually use the goggles, and it's like a virtual tour, and you can see the thing going together and what to do, that kind of stuff. So like, we're really big on the idea that we want to enable people to fix the cars themselves, right? If it's really simple, right? Unless you get into the high voltage stuff, right? I mean, everybody with any kind of technical, capacity should be able to fix the basic things on the car, right? So, like, we're going the other way from these other car makers. Like, the other car makers seem to be jumping onto this whole John Deere thing where it's illegal to work on your own car, right? It like voids the warranty if you touch one thing on it, right? Like, that to us is crazy. It's not what we want to do at all. So, so the Tesla approach, as far as like, I don't think we'll have dealerships because it just seems to be like getting to be more of an outdated model. Obviously, direct-to-consumer sales is the way to go, and then trucks, and then but like I say, we really want to like allow people to fix their own cars and modify their own cars, right? That's a big part of the philosophy behind this.
So what I hear there is that we can go ahead and we can take the voltage to 440 volts with no problem, right?
Well, there was
I think that's what I heard.
I don't know. Well, someone's got to hot rod one of these things, right? And someone's got to get,
I'll volunteer. I'll volunteer. Send it to me. I'll volunteer.
Yeah, I mean, it should, like 200-300 miles an hour, like no problem. If we can get the power and the traction down, like aerodynamically, it should be, right? It should be incredible.
Yeah.
So it'd be fun.
I see the question here. What is the typical city and highway ride in-cabin road noise level?
Oh, I don't know specific dBAs, but it's almost silent, right? Like this is, it's almost silent. There's zero wind noise, right? Zero wind noise, right? Nothing. There's zero creaks and rattles from the monocoque because it's a bonded composite monocoque, so it doesn't move. And then because of the wheel motors, there's no drivetrain noise. Like it's eerily quiet. Like it's really, really weird. Like, yeah.
Great. Yeah, that sounds great. I think someone was asking for a little more explanation. You touched on the wheels not needing power steering. Can you go into the mechanics of that a little more?
Well, it's as simple as if you imagine like the car being stationary and you got your 2 front wheels and you apply power to this wheel and maybe like reverse power to this wheel, the resulting reaction is that the wheels are going to want to turn. This one's going to want to roll forwards, that one's going to roll backwards. So eventually we can steer the wheels just by changing the direction of the rotation. right? So with the car sitting still, you can literally turn the wheels statically, and we're just doing the same thing dynamically. So when you're moving, we're just giving this one a bit more power, and it pushes the car that way a bit, right? And it's all within the controller software. This is the crazy thing. Like, we're not inventing software to do this. This is like an option now when you get the controller. It's like, do you want torque vectoring steering? And you go, yeah, and you set it, and it works. Like, it's like, you know, it's just incredible.
So your steering wheel is sending measurements of angles to the control system.
Yeah.
Okay. As opposed to mechanically pushing the wheels in a turn direction. Okay.
Yeah.
In fact, I haven't seen the question come up, but any ideas of introducing autonomy to the Aptera vehicles?
We'd like to. I mean, again, like Tesla is, they've done a fantastic thing. Like, the engineers at Tesla are marvelous, right? And the camera-based system is kind of proving the way, I think, towards not using LiDAR, right? I saw one recently, I think it was Faraday came out with a really interesting LiDAR kind of integration on top of the windshield, but it's still, you know, I've done those things before, and you end up with so much data coming into the car. Like, what you literally can't manage the data coming in, right? So the camera-based stuff that Tesla's done, I think, is great. We're heading the same direction. We've got 6 cameras on the car now. I think we're going for level 2 out of the gate, but it's not really a focus of the company, right? Like, we're not, like, for us, it's aerodynamics and efficiency and lightweight. That's really the main focus, right? So again, the autonomy stuff is getting easier as well. You know, I imagine in a couple of years we'll just better get a plug-in to do this, right?
That's what I was kind of thinking, is that we don't need the same product to be developed 100 different times by 100 different companies, that you'd be able to just buy a system and plug it in to your vehicle at some point in the future. Yeah.
That's what we're seeing now with, like, the tier 1 guys, with like the Borg Warner and the Danas and like these level companies, these like tier 1 suppliers, the big guys. They're all jumping into the game on this stuff, and I'm pretty sure they're all going to come out with autonomous modules in the next couple of years. Like, the main vehicle control system is able to do it with kind of brains. We're literally just adding cameras, and on the drivetrain system we have everything we need. We've got the power brakes, power steering. So, like, it's again, it's all getting much easier, right? And what it seems to me is that we're going to see more companies like Aptera coming along, because people are going to realize that to put together the pieces to make a professional vehicle is so easy now compared to what it was. I hope more people are going to get into the game, and they're going to come out with their own vehicles and their own crazy things. And we're going to see more of these kind of really creative, innovative designs, right? That not only push the envelope on, like, efficiency, but also just what we see in the world, right? Like, what does a car look like? What does the future look like? You know what I mean? Like, what do we want to see when we drive around? Like, I'd like to see more cool things, more things that are more weird and more, you know, interesting, you know, and more thought out, more intelligent. You know, this is so.
Well, one of the that has been traditional here, it's kind of gotten quashed by the COVID, but we have the art car parade every year in Houston, and I'm sure there are YouTube videos of it. So if you want to see some different looking cars, just find a YouTube video of the Houston art car parade. And unfortunately, a lot of times people are using kind of old and not so good shape and highly polluting base cars to start with. So I never actually been right up next to cars, but I've heard that it can be hard to breathe next to some of them putting out so many bad gases, because they're on things that are ready to go to the junkyard, and people have saved them and turned them into art cars. But they don't drive around a whole lot, so I guess we'll excuse them for one day a year of driving a little bit. But the styles of cars are just phenomenal that people have come up with. So you might want to look up those videos. So how are firmware updates done?
It's all just it's Wi-Fi, I think.
Okay, so you go the Wi-Fi route. All right.
Same as Tesla. Same as Tesla. Okay, so the supercharger we're not officially using yet. Not using. So that one is TBD, and the production time one. I think a week ago we were like 60 to 100 orders. So we're probably well into next year at this point for deliveries for if you made a reservation today. Yeah, I think the target was, I think, 5,000 for the first year, then ramping up to 8 to 10 for the second year. So
and I see Robert is claiming one of those orders. Yes.
Nice. Yeah.
Very good. Very good. Yeah. Okay. So other live questions from folks. Anything in the aerodynamic Zutech that you want to ask about?
I'll share one more interesting story on the aerodynamics. I've actually got to run in a minute, but Miles Wheeler is the chap who did the aerodynamics on the car. And Miles Wheeler is the son of the gentleman who started CD Adapco. So he grew up with fluid dynamics in his blood. And we hired him when he was just out of school in his early 20s. And we changed something on the rear skirt of the car. And Miles said, well, we're going to have to change the front skirts then. And we said, well, we're behind the front skirts. What are you talking about? And he showed us how if you change something on the back of the car, it affects the pressure on the front of the car, and you have to change the front as well. And it was remarkable to be working on a project that was so finely balanced that one little tiny change at the back actually changed the pressure wave of the front. Like it was absolutely incredible. The level of simulation he was able to achieve on this vehicle, like it was absolutely incredible. And it was all based on, I don't know if you guys know the story, but Steve's inspiration for the car was a shark. And actually when a shark comes down to the ocean floor, it can't actually get down to the bottom because of the ground effect, right? So it arches its back up to be able to get down on the ocean floor, which creates the water to go up and under the shark, which actually pulls it down. So the shape of the Aptera is based on a shark as it's coming down to the ocean floor to get the cambered airfoil. So it's like a cambered airfoil mixed with a shark shape kind of thing. So that was where the shape came from initially, and then we just refined it and refined it and refined it until the whole thing was so well balanced that we had this beautiful flow. And yeah, it's
that's smart to use nature as a model. Yeah,
it really is. It really is. You just got to watch it, right? You just got to pay attention.
So John is asking, when is the IPO?
Actually, this is an interesting one. I don't know how much I can share here, but you guys saw that the first, well, there's been 3 fundraisers right now, and they're all done on WeFunder. And in the US now, you've got these new rules that allow non-accredited investors to invest in private companies, right? We're thinking that we can actually do the next 2 rounds to get us to like a 50 million valuation without diluting the company at all. Like this is brand new territory, right? Like this, no JV, there's no banks, right? There's no private investment at all. It's all done publicly. And to be able to raise $50 million without bringing on any outside investors, this again is remarkable, right? And it's due to these new laws in the US, these banking laws that allow these micro loans and people to invest in the company. So I don't think we'll do an IPO. Like to be in a public company is horrible, right? Like you will probably know this, like public companies are the worst, right? You can't do anything without getting permission from everybody. Like you just can't move. So I think we just had to keep it private and just build it organically, right? Sell the cars and make money, sell more cars and make money, and you know. But if we can raise enough to launch the vehicles without having to do any kind of outside investment, like that's brand new. This is brand new again, right? Like this is a brand new world here. So.
Yeah, we've all seen Dell go from private to public to private to public. Yeah, with the Dell computers. But okay, and so again, did we cover costs? Anything else you want to say about costs?
No, I think we're coming out at like 20. It's like starting at 30,000 kind of thing, right? But you know, that's probably realistic. You know, it's probably you know, a lot of these companies come out and they're like, oh, this is the price, and then they actually come out that's not the price. Like the cost to build a car isn't too bad, right? Because it's composite, we don't have a ton invested in tooling, right? Like a fraction of what a regular steel car would have invested upfront in tooling. So you don't have to recover that cost. And then it's really just the batteries is the primary cost, and then the motors and controller. Right? Those 3 things is like 60% of the bill of material cost. So like they're really not that expensive to make. So 29,995 is plenty realistic for the volumes and the prices we're seeing from components right now. So yeah, it could be cheaper too, right? I mean, as the price comes down, I mean, you know, we all want to be open and kind of honest, and you know, we're not in it to make money. Like we want to make money, but we're not. That's not the driving factor here, right? Like we're out to kind of show the world like what we can do if you put your mind to something. Yeah. Oh, I couldn't hear you then.
Well, I'm muted, so nobody was doing me on that when my mouth was moving, maybe. I was just asking Mike Vutek if you wanted to ask something about the aerodynamics.
I haven't had a chance to look at the vehicle depictions well enough to ask an intelligent question about that. But one thing that would be interesting to ask about, since rolling resistance is important, what kind of tires and what profile? How wide are they? You know, how tall above the rims and that kind of thing. Anything worth talking about there?
Not really, nothing really out of the ordinary. They're it's a 17-inch rim on the front, 16 on the back. I think it's a 45 profile on the front, 40 on the back. We just want to get a bit better pothole impact resistance on the rear tire because it does hit potholes. Just want a bit more height on the sidewall. But they're just normal tires. They're just Continental. One of the issues is replacement stuff, right? If you get something too outrageous, like you use like the BMW like i3 tire or something like that has low rolling resistance, you can't get the things. You get a puncture somewhere, you're special ordering a tire for your car. So we wanted to use something that was available, that was the best we could do with what's easily available, right? And reasonably priced, so.
That seems very logical, yeah, because nobody would want to be not able to get a new tire on their vehicle when they need it, and therefore not able to use their vehicle. Yeah,
exactly. Yeah.
And you've optimized so much of the rest of the car that it seems like a good tire that's available would give you marginally less range than a super tire, as you say, available doesn't do anybody any good.
Yeah, like people don't realize this, but the drag of the discs on a disc brake, like when you're just driving down the street, is as much as like the rolling resistance on the tire. So just having a little spring that pulls the pads back on the disc brake gives you like a massive increase. So if you can do those kind of things and get these massive increases, then you don't have to be so selective on stuff like tires, right? So.
Yeah. It's kind of sad then if the standard old line car manufacturers are using disc brakes that actually don't have that extra spring to eliminate drag. That's really kind of sad, but I guess that's just part of the inefficiency of gasoline drivetrains that they just didn't bother.
Well, if you had that when you hit the brakes, you'd have to push the pads in before you got contact, so you'd have an instant where you didn't have any brakes, right? But with the EV, your regen is what you're using for the brakes as much as you can, so you're not even using the brake pads most of the time, right? So it's
okay, so that extra day of time is not a factor. Okay.
It doesn't matter, yeah.
So what about what about the materials and the formation process for the transparent parts of the fuselage?
Transparent parts, like the
yeah, you got to be able to see out, right? So
like the windows, you mean?
Yeah, the canopy, if you would.
It's glass. It's regular glass. It's regular laminate on the front and tempered on the sides. It's normal.
Okay, so not Lexan or Form Plexi or anything like that.
No. It's ordinary car glass. Ordinary. Yep. Nothing special there. We do have, like I said, the solar panels are under the resin, and we do have we're using a UV cure resin with a UV inhibitor in it to try and get as much transluminosity we can to the solar panel through the resin. That'd be like a thin layer of resin on top of the panel. That's really the only trick to try and make something transparent, is so we don't get too much blockage on the solar panel. I think.
Are you looking at all at some of these cells that are coming along that are double junction? Some of those are looking like they might get about 30% conversion efficiency. Would that work with your resin system, or have you looked at that?
As long as we can get enough flexibility from the cell to conform to the surface, and the challenge was trying to get a simple surface flex and not a compound surface flex. Because obviously they're not going to flex in two directions, they'll flex in one. So we've had to kind of cheat them and position them so that we don't get too much compound curvature. But we're also looking at we've seen spray on solar panels, right? I mean, terrible efficiency, but promising, right? Maybe that's something that is going to improve, right? I've seen there's a car paint now called Luminor. That actually, it's like electromagnetic paper, electroluminescent paper, but you spray it on your car and then the whole car lights up. right? So obviously a solar panel is the same thing the other direction. So I mean, if we're getting progress there, we should be making progress in spray on light capture, right, technologies. And if we can get the whole car covered in something that captures light, that might be more efficient than just having panels on top kind of thing. So, but again, just to get in on the game with solar panels, like we have enough, we can get enough range now. We have the solar panels now. If we start using them now, we're in the game, and as technology improves, we can bring that in and replace what we have, right? But we have to get in on the game with the solar panel stuff now with what we have. Otherwise, we're not going to be at the point where we need to be when this other stuff comes out, right? So. But listen, I really do have to run if that's okay. I gotta go.
Okay, one maybe yes or no question. Is the car eligible for federal tax credit?
I don't know. I don't. I believe if this is an auto cycle, it might not be. I don't know.
So
I think
something for folks to.
I think that
they're working on.
Yes, there's legislative efforts being made to get a federal, get auto cycle added to the federal tax credit.
Oh, nice. Oh, good.
Okay. Well, appreciate it. To leave you with one last question that just for you to think about. Someone asked, do you get any drivers to prototype? So with that, thanks a lot, Nathan.
Oh, I think so. Yeah. Yeah. No. Yeah. If you're in the San Diego area, I mean, and stop by the factory and come meet the crew, and
All right. Here we go. Everyone's got an invitation. Okay. So
awesome.
Thanks again. This is really great. Everyone got asked their questions. Yep.
Yeah.
Hey.
Thank you for having me. I appreciate it. So.
Okay.
Excellent,
And you're
Nathan.
welcome
Thank you
to
so much.
any first Thursday meetings you like, Nathan. Thanks.
Thank you. I'll see you next time.
Okay. And that's great that we got to ask lots of questions and learn a lot about the vehicle. What was going through my mind, whenever you see these science fiction movies, the vehicles of the future are always very aerodynamic. And it's like, why can't we have those aerodynamic vehicles on the road? No. Yeah. I was reading something the other day about how the fronts of pickup trucks keep getting taller and flatter, particularly in the opposite direction. So not only does it make them aerodynamically efficient, it also makes them more dangerous for pedestrians and other people too on the roads. But it's the way the manufacturers are going, because it's the way the marketing tells them to go. So that's what we're seeing in the way of pickup trucks. Of course, we're all expecting some electric pickup trucks to be coming out, Rivian and others. So we'll see what kind of forms they take if they come out. So for this second half, with all the news that's out, I thought we'd talk about some of that. And let's see, Colin, you said that you were going to come up with some things. Would you like to, or you want to have a little bit later in the second half here?
Hi, yeah, this is a dangerous place to be with this group. I'm going to be sharing some headlines of EVs. And you saw, I'm sure a good number of you have already seen these, but this was a few items that caught my eye. Let's see if I can share this, make this work.
Dave, while Colin is looking up that and about to share our screen, do you mind if I say something about Aptera just to finish that up?
Yeah,
Sure.
yeah, please.
They've got a program at Aptera called City Ambassadors, and they pick people that would promote the vehicles around the country. And I'm the City Ambassador for Aptera in the Houston area. So if anybody has questions, I do have a investor presentation that I'd be more than happy to share with anybody. It's an open source presentation that explains a lot about Aptera. They also have a referral program like Tesla has. So if you use somebody's referral, and you can use mine, they'll give you $30 off the car that you order. And one other thing is that when you build the car, the website is still not as refined, but there's an options section to the website where you can get a level 2 autonomy hardware. You can get a higher performing stereo system. You can get a camping kit, which there's a whole bunch of things that you can order as packages for the car. So if anybody has any questions, just contact me. If you want the presentation, Dave, if you want me to distribute it, I'd be more than happy to do it. It's a nice PDF, actually a PowerPoint that has a lot of information on the company. And with that, I'll leave that.
Yeah, I think that would be a good thing. Let's see how things go as we continue the second half, whether you show it tonight, but definitely put it on to the website tied to today's meeting.
I'll do that. I'll send it to Colin and he can put it up on the website.
Perfect. All right. Okay, Colin, yeah, I see the screen share coming up. Very good.
Yeah, it should be visible. You
Yep.
see it?
Yes, I do.
Okay. So the first thing that I was looking at was looking at vehicle sales in Europe. They seem to have a record electric EV sales. And my first thought was the last I knew that was probably Tesla Model 3, but it's not. I'm surprised to see the Renault Zoe, which I'm not even sure what, I've never seen one. And the Volkswagen showed up, the ID3 showed up, which is, I found that quite impressive. And Volkswagen is counting on selling the ID4 this year too, I understand. So this is just another indication of the many headlines we're seeing on EVs in the news. This is not only in the, I mean, at Wall Street Journal, it's mainstream news as well as the electric and clean tech. Here's another one. Davidson's been making and fooling around and teasing electric motorcycles, and now it appears that they are getting very serious about it. Which brings up the next one. This is a video I'm going to play for a company that is apparently in Texas. I've never heard of them before, but check this out.
Ride underwater. Wow, that's.
I don't know where in Texas it's being made, but it's looks interesting.
So that one's actually up in North Texas, up in the Dallas area.
Okay.
They also make a UTV and they also make a quad bike as well.
Ah, okay. I heard about the Extreme E off-road racing, which is if you've heard of the Formula E, it's a similar level of competition. It sounds like it takes place in areas all over the world, and I found that another maybe nail in the coffin of gasoline. When you start seeing this type of racing, then you know, to me, it makes it more real. And
yes,
then
it certainly does.
I think we know that the commercial activity is probably, I mean, there are companies that are willing to spend money on this because they know they can save money. And the Amazon seems to be a big push behind this, and it may be for very efficiency reasons, you know, that they're, it's not, I think these decisions are being made not just to look good, to look green, but to, it actually makes money sense. And that's why you're beginning to see all this activity in the commercial area. And then, of course, you probably heard this one, that GM has made a big announcement, I think, for them. That's a big risk for them to take. And which brings up the Super Bowl commercial that they're going to, oops, I lost it.
Did you know that Norway sells way more electric cars per capita than the US? Norway. Well, I won't stand for it. Come on. Never mind.
My screen is up there. Anybody seen this yet?
No, we want to see it, but we can't see it.
Okay, let me try it a different way. It's
Top of our list for sure. While Karen and Mina wait for offers after a successful
some reason my
in Fort Worth,
It's a great commercial.
great offer on their quick flip.
5 days after open house, we accepted an offer for $2,000
no.
and $171,000.
Dale, can you mute your microphone?
Sure. $1,000 profit for this 4 week.
Thank you.
Yeah, I'm not sure exactly what's going on here. I'm getting for some reason my PowerPoint is not cooperating.
Good to know that that commercial will come up at the Super Bowl. I'll certainly be watching that one, and
oh yeah,
then I'll replay it again after. Yeah.
Is it on YouTube, Colin? Where did you get it?
Yeah, that's where that it is. It's pretty much everywhere.
Okay.
So they're putting their commercials out before the Super Bowl now. Okay. I know that they're available afterwards, but
let me try this again. Let's see if this. Let's try it now. I don't know why now. Let's see. Let's try this.
Yeah, we can see it now.
Did you know that Norway sells way more electric cars per capita than the US? Norway. Well, I won't stand for it. Come on. Never mind. With GM's new Ultium battery, we're gonna crush those losers. Crush them! Let's go, America. Keenan, Norway's out EVing us. Wait, what's this?
Oh, it's my daughter's birthday. She's really into pirates lately.
I don't care. Grab an EV, meet me in Norway.
Okay, can I say goodbye to my family?
Nope.
All right.
Aquafina, sorry to disturb you, but Norway's beating us at EVs.
Nuh-uh.
Uh-huh.
Nuh-uh.
Uh-huh. Meet me there in an hour.
Can I ride with you?
No! GM's Ultium battery is made for all types of vehicles, so soon everyone can drive an EV. Oh!
Why didn't we all just go together?
Knowing Will, he's probably flying private.
Hey, Norway, listen up, you fish-loving! Oh, this place is adorable. Damn it. Where are you guys?
We're in Finland. Where are you?
I'm in Norway.
Norway? You're in Sweden.
Damn it! Did you know
that's
that
wild.
They spent some money on that anyway.
Yeah. In typical Super Bowl ad style, got to spend money on it to make it memorable.
I'm glad that they're making the commitment, but the comments have been, this is from a company that doesn't have a product to sell, which is not entirely true. They have a bulb, but that, yeah, they're behind on their advertising or way ahead on their advertising.
Yeah, they're about 15 years behind on their Ultium line because they haven't actually developed anything to go with it. They also don't have any product planned for at least the next 5 years, and they don't have any manufacturing set up for at least the next 10. So good luck to them.
Yeah.
Yeah, there's been comments before about the Bolt being large South Korean vehicle, and it's true that the short term they don't seem to have much going. They're making announcements about 2035, which is more than a decade away. And I saw that Ford just announced they're upping the number of billions of dollars they're going to be investing too, but it's future products.
Yeah, my last comment is if you see EV news that you'd like to share, please do it on our website or on our Facebook page.
All right. Yeah. And so Robert Sanchez, you were emailing me that you might have some things to talk about tonight as far as news. Okay, I don't see video from you, Robert. I see a muted box. I don't know if you're stepped away from your microphone. We'll come back around to you, Robert Sanchez. And the Sweet Brothers, what kind of projects have you guys been working on lately? I know that you've always got something up your sleeves.
Yeah, all right.
That was fun.
I don't have any right now. I gotta
mute this.
Okay.
Yeah, I don't have projects right now.
Okay. With the batteries getting to be more common from vehicles, I thought maybe you'd have something going, but think about what you want to do in the future. In the same way Robert Powell is planning projects he's got coming up in the future. Thinking of Zutech, seeing your name here on the list again, I'll let everybody know what I sent you to Mike an email. So some folks may be familiar with Mike's trials with a trailer behind a Model X, a camping trailer. And there's one particular design that he's got. Well, it's out in West Texas, Van Horn, in a supercharger parking lot back in the middle of December. And I drove up in there with family members, and there was a camper separated from its Model X. And the Model X was overcharging. And I saw father and son over by both the camper and the Model X. And so I started chatting with them, as typically gets done when someone stopped at a supercharger. And they were coming from Louisiana, heading out to California. And they were talking about their experience, they would drive and things like that, pulling their small camping trailer behind their Model X. So I got some contact information, and I'm going to see if those two are able to talking with Mike Zutech when he has some time. I'm thinking that those guys would all really like to compare notes and things like that. So it's really kind of amazing what you find on the road when you're charging a vehicle. So Mike, we'll see what we can do schedule-wise to get folks on a phone line together or whatever. It's kind of in the world of projects, what Mike has told us about his projects and what these folks, the father and son, were learning as they were collecting data from their travels with a camping trailer behind a box. We all know batteries in cars are getting bigger and they're getting to be more aerodynamic. Well, aerodynamics really kind of hurt a lot with pulling a trailer. I also saw a news report. It was more a comment to a story of folks out in California. They were going to be attending kind of activity somewhere in California, and they were starting in Utah or someplace. And they didn't research their abilities very well. They started out pulling a trailer behind their vehicle, and decided after getting about 100 miles or so that they were going to turn around and go home and take a gasoline vehicle to pull the trailer many hundred miles. So glad that they didn't get stuck somewhere. But those are the types of things that folks are learning out trailering, which I thought kind of important. Anytime you do something that hurts the aerodynamics, whether it's putting bikes up on top of a vehicle on a roof rack or any other things, you can hurt the aerodynamics. And people are used to their inefficient gasoline cars, and hurting that efficiency a little bit doesn't affect the overall range very much. But on an electric vehicle that is optimized, as we heard about with the Aptera, you do something that changes that, and you're not really going to get the range out of your electric vehicle. So,
one thing about, sorry, go ahead.
I was just going to say, do you happen to know what type of trailer it was?
I can look. I think I took some photos in the parking lot, and if we get them on the phone, we can certainly find that out. It was not the same type as yours, because I brought up what yours was to them. It was small, but it was not the same brand.
So an easy number, well, not that easy, but 530 watt hours per mile is what I got on my long trip, our 4,700 mile trip. It's close to 500, I think, with a little bit more fussing around with the aerodynamics, and that's at 60 miles an hour with the X. So you've got to have the drag of the X is in there too. It's not just the trailer, but that's about what you can like, about a couple of miles per kilowatt hour with a relatively conventional but lightweight trailer. And I think there's a ton of room to make that better, just like on the cars, making them more aerodynamic. It's all about the aerodynamics. I've done the numbers, and the aerodynamics is what's limiting it. It should be possible to do much better.
I do remember these two folks saying that 55 miles an hour is what they were doing, which on I-10 across Texas, I mean, it's like 85 is the rule pretty much, but they knew the physics, and they knew they had to go 55 to make it from one supercharger to the next. Yeah.
One thing is that the resistance to friction by the aerodynamics goes up by the square as you increase speed. So speed really affects when you put more drag on the vehicle, really affects. So there's probably, it would be interesting to have some kind of a calculator that would figure out on your, in how long it takes you to go somewhere, what the optimal speed for the drag that you have would be. Michael, you're a numbers crunching guy. I know you use 60 as a standard to see what you got, but I wonder, instead of taking the interstate, you take the access road instead, and I wonder if that would, you know, doing 45 instead of 60, the time might be longer, but you might not have to do the charging stops. Although with the Tesla, you're really charging at 400, 500 miles per hour of charge. So maybe it's better to drive a little faster and get the high speed charging.
A very interesting thing along that lines, if in fact the Cybertruck does have a 200 kilowatt hour battery in it, you will be able, my Tesla will start slowing down the rate at which it's accepting power, even though it's a 100 kilowatt hour battery. It starts to slow it down a little bit beyond, let's just call it half full. By 75%, it's only doing 60 kilowatts. So it's slowed down by then a lot. If you double the battery size, you're going to be able to pull the maximum power out of the supercharger for a much greater portion of the recharge cycle. So in effect, you'll be able to get, against a constant consumption of energy by the trailer, you'll be able to recharge more miles more rapidly because you'll stay, if it's 135 kilowatts or whatever the one you happen to pull into is. That's one of the very interesting things about it. And I've got my order in. Whether I'll actually go through and get one or not, I don't know, but probably. And that would be one of the advantages. Not only 500 miles of range they claim, we'll see when it's really out, with no trailer, but that you'd have longer range and much faster recharge. So that those numbers get very interesting when you start playing with a different vehicle in addition to speed variations.
Have they said anything on what the towing capacity is going to be?
Yeah, it's 13,000 pounds. It's got a ridiculous amount of power. Well, that's the 3-motor configuration. But I think if you're going to do it, the crazy thing back when I ordered my X to go from the 2 to the 3-motor configuration was $30,000 additional. On the Cybertruck, it's $10,000 additional, and you're getting some battery. It's not just the motor, you're getting a bigger battery in the bargain. So the relative value per additional dollar spent on the Cybertruck is enormously better than it was back when I got the X. And that's not that long ago, 2018, right? We're in 2021. It's changing very rapidly.
Yes, I think Purpose saw the battery day presentation from Tesla with the new cells being more energy dense and being able to be packed more densely. And I guess the battery pack becomes part of the structure too in new vehicles. So yeah, a number of things. And these other manufacturers, Ford has announced, others, Chinese makers have announced, are really moving forward in batteries.
And going back to the monocoque, in essence, what the Cybertruck is, it's a stainless steel monocoque. The reason it's got all those angles on it is it's such high tensile alloy that you can't form it. You got to make it out of sheets because you can't bend curves into it. But it is an active structure. It's not a frame and body. It's an active body, which puts the load carrying as far away from the center as you can get it, right? It's right out there on the skin. That's the monocoque argument. We just heard it for the Aptera, and it's also going to be true for the Cybertruck. And what that does is it keeps the total vehicle weight reasonable, even though you're going to throw 200 kilowatt hours inside of it. An absolutely giant battery if they keep the specs. I heard an interview with Musk. He said, yeah, it was with the Jay Leno one. He says, you got to make it about 5% smaller so people can get it in their garages. So they're going to redesign it a little bit, but so far I haven't seen anything saying that they're going to change the basic specifications.
Michael, I would question that claim, because if you listened in the investor slide deck that Musk gave the other day for the Q4 review, he actually claimed that the chassis is now a frame on chassis for the body, and the truck bed is a cast, because they're using the new 8,000 ton press for the rear section, but the cab, the chassis section, is still a frame on chassis.
Ah, that's very interesting information. I hadn't caught that presentation. Thank you for the update.
Yeah. So the thing is, so the two things that you mentioned. So one, they've actually invented the new 8,000 ton press, which supersedes the 6,000 ton press that they just set the record on Giga Shanghai. And then on top of that, the new battery cells are in the pilot plant in the Bay Area. They've reached 5 gigawatts of production, and 10 gigawatts of production, and they're on track to reach their production mark of 100 gigawatt hours by the end of 2022. And what you were talking about, the semi truck, is not 100% true, and I wanted to step in, but it was previous. So in the investor slide deck, it's not that the batteries aren't available, it's that they can't manufacture the batteries quick enough to validate the Cybertruck, the Semi, and everyone else. It would be financial suicide to do it, because they would have to give up one of the other lines to give the batteries to them. Either they would have to give up the commercial storage, or they'd have to give up the Model Y in Shanghai, or they'd have to give up the Cybertruck. Either way, they'd have to give up the cells somewhere, and so that's why they've elected to push the Tesla truck through another year of production cycle.
Interesting. Is that presentation available anywhere, or is that something you had to be there live to get?
You had to be on the investor slide deck. I believe it is now public information on the investor site for Tesla. I can look and see if I've got the criteria, and I can send it to Mr. Hansen.
Excellent.
Yes, yeah, we'll get out the links or whatever that you can send me. Good. Okay. Robert Sanchez, are you available? We talked a little bit about some things that you wanted to cover in an email. Or if not, I'll throw it open to, okay, Colin, what do you got? I see Model Y and some Chinese characters, so.
That would be the 6,000 ton press. I can talk to this one. So this is the full video that they've got of the 6,000 ton press that they just released into production at Shanghai Tesla.
Okay, so that's that big new single piece casting that replaces 70 individual parts that used to have to be connected together. Okay.
Correct. So that does 6,000 ton press, and it does the rear 3/4 of the subsection. It will replace 67 pieces, not 70, but 67 pieces in total. And then the 8,000 ton, which is coming for the Cybertruck, will do the whole entire bed in one piece.
He's made some comment about he wanted to make a car body like a toy, die-cast car.
Yes. He actually mentioned that. So I've just posted the link to the investor portfolio from Tesla, which is public knowledge. It's ir.tesla.com. And you can go in there and you can listen to the whole entire investor portfolio. If you need a good nap time, I strongly suggest that you listen to that. You'll be out in about the first 4.5 minutes.
So everybody says cast, but it's really a forging. It's a stamp. Right? It's
no, it's cast. It's a cast. So they have the stamp sheets, and they actually will cast them as a press cast.
So I thought a cast was where you had a mold and you filled it with material.
So cast in all mechanical terms can be any way of deforming a material around another object. That is the true definition of it. So they are technically doing a cast, but it's also a forging as well. So technically it's a hot cold cast form. if you want to get ultra lengthy on it. But yeah.
All right, very good.
That's good to know. Yeah, I kept seeing the word
Precedent's
cast, and I think of cast as a liquid or something. But okay, that's good to know the definition of cast.
Yeah, they're putting the sheet in there and then stamping it out. It's 6,000 ton press.
Mm-hmm. Yeah. So again, it shows the pushing the industry where the legacy vehicle makers have not decided to push things forward. They've been happy with what they've done, and so yeah, this is really something to see this vehicle industry shaken up. Mm-hmm.
You know, I wanted to say something, and Colin pointed it out, and you did too, Dave. But we've got GM putting in, I think they're up to 27 billion, but let's say just big quarter, 25 billion, 30 billion. You've got Ford doing the same thing. I think Ford's number is even bigger. It might be 27 billion. You've got Volkswagen investing up to 50 billion in the next decade towards electric vehicles. You have this mass of capital happening. It's phenomenal. The for the guys that have been around the Electric Auto Association a long time, I think of Dale Brooks and others. We're living it. It's so exciting. It really is.
Yes, indeed. So I see, Colin, you put out another picture there with the Ford. That's good. Yeah, Ford, of course, has decided to invest the Mustang name into their electric vehicles. Volkswagen being mentioned, yeah, so they've got their ID3, which is only in Europe, and ID4 is going to be worldwide, I guess. And I just saw a picture today. They have an ID6 that they've started showing. So Volkswagen wants to go in really big. I always kind of compare Volkswagen and Toyota. Toyota doesn't seem to be jumping onto the bandwagon much. Because, of course, as the sizes of different automakers were being compared over the last few weeks, they talked about Volkswagen and its size and Toyota and its size. But
well, Dave, Toyota has also come out and said that they do not support the EV movement. They still believe in hydrogen as the way forward. That's why all their drivetrains are more towards the hydrogen plan. They're not planning to go in an electrified fashion anytime soon.
Okay, so their Toyota Prius is as far as they want to go then.
That was a dog and pony show that they put on, and that's as far as it's going to go.
Mm-hmm. Well, I think the Priuses have sold pretty well around the world, and then of course they said they weren't going to do a plug-in Prius, and then sure enough they did do a plug-in Prius, which I think sells in decent numbers. In a lot of ways, I think you can't compare the production numbers of EVs with the production numbers of certain models of gasoline vehicles, which get produced in the millions per year. But I don't know offhand the Prius as standard hybrid, conventional hybrid, and the Prius is a plug-in hybrid. I don't know what the numbers are, but
of course, Toyota does sell an electric car in China. Everybody sells one in China. They have to.
Yeah, I agree with Robert, and Colin puts out a really good point, and that is that Toyota, of the main manufacturers, is probably the most reticent in EVs, the Toyota Lexus brand. However, the size of Toyota and the innovation and engineering capability of Toyota, they may be later than others to the EV movement, but it goes back to my analogy of a big parking lot of cars with different sizes and shapes and colors and brands. And you have people that are allegiant to brands, and they will, you know, as demand, as more and more EVs are out there, these companies will have to transition to have a line of EVs. And as Colin said, they have to do it in China, and so they do. So I think, and as Nathan said, you know, the ability to develop a vehicle today is so much faster because of all the engineering tools and all of these suppliers that are providing all these phenomenal parts that are talking to each other. And you know, the Hummer development, I think, was 3 years. 3 years for a ground up, totally electric vehicle by General Motors. And I think you will see a lot of players and a lot of innovation in this next decade. It's going to be, there are already these architectures, Volkswagen's architecture, Mercedes architecture, Lucid, Tesla, of course, the skateboard, making the battery down below the vehicle part of the structure, putting the load points on the corners. It's happening. So, but Toyota it's interesting how reticent they are to acknowledge publicly the movement to electric vehicles. We'll see.
Well, and another company that seemed to be behind Fiat Chrysler, of course, just recently merged with some French competitors, and they came up with the name Stellantis. And I mentioned that to one of my family members, and it happened to have the stock symbol letters there. And they said, that looks like Tesla just rearranged the stock letters, stock symbol letters, and you get Stellantis's stock symbol. It's like, I wonder if they thought about that when they were picking those letters. So yeah, we'll see. Of course, we know that credits have been bought and sold between companies and so forth, but yeah, Fiat Chrysler seem to have been slow, but some of the French companies have been going a little faster. The Zoe was mentioned, and so we'll see what Stellantis is going to do on the world stage now that it's been formed. And yeah, there's the players in China. People wonder what's going to happen in India. So yeah, there's a lot there. So I see, Robert, you put some text in the chat. Do we want to have either at the beginning or end of meetings a current event session where we inform attendees on what is new in the world of EVs and alternate energy? Maybe have a section on the website for articles that I BCC some of you. So yeah, I think that would be a good thing. So Colin, maybe we can talk to you about how to do things on some of the website. And so one of the things I was thinking of for this year, we might want to look and see if Wix is still the software we want to use for our website. If folks have ideas, if they've had good experiences with something else, WordPress or something else, let me know, and we can see if we want to use something that would meet our needs more. I think we want to stay with the HEAA.org domain, which we have. But we can certainly port things to something else or continue to use Wix if that's what we're comfortable with. But I like your idea, Robert Sanchez, that we can put some other info on the site. So the news seems to be coming fast and furious. And so things that might be particularly relevant to our members. Of course, I also like to remind folks that the electricauto.org, so our national organization's website, also has a lot of information. And I believe they've changed the policy since they've gone from the written paper versions, the printed paper versions, to having all electronic current events, whereas before it was limited to members, at least for the first month. And I believe there's like about 1,300 members or so, paid members worldwide, not only US, but worldwide. But they did advertise that their distribution of the electronic current events goes out to 25,000 people who subscribe. And so they're wanting to hit a lot more people. So they've changed that policy, and of course are cutting down fewer trees. And so that's always a good place to go for a lot of information. I think there's some very thoughtful articles written up there, and of course links to videos and things like that, which work better in something that's distributed electronically as opposed to something that's printed. So that's always a good source of information. But yeah, anyone who's interested can email me, and we can see what we want to put on our website in terms of links, however we want to get those links on there. And as I said, what software we want to use that makes it easy for folks.
Yeah, I'm no expert when it comes to website. I am absolutely the last person that should be doing this, probably. I probably just because I'm the retired one, I guess. But the beauty of the evil Facebook is anybody can post to it. It's so easy. And the HEAA website is not as easy to post to, and nobody looks at it.
Well, Colin, I want to thank you. I think all of us do for your work, because all forms of communication. I know we probably the website is maybe along the lower hit piece of communication. However, we have folks occasionally that contact us because they were doing website searches.
It's true.
And so all of these forms of communication, I think a successful organization uses more than one way to communicate, because different people and different parts of the market have different ways of communicating. So thanks a lot for all your work. We really do appreciate it very much.
I'm happy to do it. There's probably 6 more websites that we should be on that we're not. You know, LinkedIn. I mean, there's probably some I've never heard of.
Well, certainly expanding would be good. Yeah. And I do know folks go to our website to do the registration, just because that's the way we've set things up for our monthly meetings. When someone is registered, they've got a link that's good from one month to the next and so on. But I know folks, especially like our speakers and so forth, I direct them to the website so that they do the registration and they get the link that way.
I think you have to have a website. You may not use it that much, but you have to. I would just like to wish it was more, that it operated more like Facebook, because everybody knows how to do that.
Problem is that some of us are morally opposed to Facebook.
I hear you.
Yeah, I've been reading up some more on WordPress, and I think their statistic is that 38% of websites are written by WordPress. Some end with xxx.wordpress.com, and others, the domain that some organization is paying for is all that you see. So you may not know that it's in WordPress. So whether that's maybe something better, we can discuss that.
I run SV650E from WordPress, and I love it. So.
So testimonial for WordPress.
I've got a custom domain and everything. I pay $49 a year for a custom domain and free uploads and anything that I need on there. So.
All right. Yeah, $49 a year is not bad. I think right now we're paying $99 a year for the Wix. So yeah. Good. All right. Anything else folks would like to bring up? Anyone's welcome to unmute.
I messaged you privately, but I'll just ask, can I make a shameless plug about my podcast?
Yes, please.
So many of you know, last year was fully charged. In fact, it was a year ago, the other day. And I met up with the gentleman from 2-Bit Da Vinci, Ricky Roy. Well, Ricky and I have become very good friends. And over the last 3 months, we've actually put together this investing podcast in regards to EVs and sustainables and green energies. So if you go to the YouTubes and you search for 2-Bits and Cents Investing, and I posted the link in the chat channel. We go live every Wednesday at 7:30 Central Standard Time, and we will talk about all of the EV activity that's happened during the week. And we'll pick an activity, or we'll pick a subject. Last week we kind of had a wish-wash session because we were talking about the influx of the GME stock and how it had affected the EV trade world. The week before that, we were licensed to actually rebroadcast the Tesla investors broadcast. So we literally had it live, and we were giving our comments and feedbacks as of that. Before that, we took a deep dive into all the legacy automotive manufacturers. So we took a deep dive into GM, and we debunked all of the battery pack that they have. We took a deep dive into Volvo and debunked their battery pack system and their setups. So I know that you guys enjoy it. So if you want to listen to me ramble on for an hour, you're more than welcome to come and join the chats every Wednesday at 7:30, and come join the podcast.
Where is it, Robert, and what is it?
It's on YouTube. If you search for 2-Bits and Cents Investing, I sent the link in the chat. It's in there right above Robert Sanchez's message. If you go there, you can subscribe, and then we release our podcast on Wednesdays at 7:30.
All right. Thank you.
All right.
And just as a forewarning, next week we're actually talking about lithium, batteries, minerals, cobalt, and good investing strategies for those guys. So.
Nice.
All right. All right.
You
Good.
should put that on our Facebook page.
I can do that.
Yeah,
Good.
yeah.
Good.
You can directly, yeah. As Colin said, anybody can put things on there.
Absolutely.
Mm-hmm.
I mean, that's what you do when you're unemployed for the last eight something odd months. So.
Yeah, we know it's been a rough time for a number of folks. It's really, yeah, sorry to hear about that, but hopefully things are looking up. Okay, other things that folks want to bring to everyone's attention. I think it was really exciting to hear about Aptera. We had heard about them way back when, and then they went quiet, and now they're back and ready to produce vehicles and sell them. So that's great. Efficient vehicles that people can get on the list and buy. So, okay. All right, we'll wrap it up then. Appreciate everybody's time. That's the valuable thing, that we're all spending our time here together with each other. And so next month, we've got Bailey to be talking about some incentives and things like that. And so I think that'll be interesting on March 4th. So 4 weeks from today. And with that, I'll close and say good night to everybody. Okay.
Good night. Enjoyed it very much. Good night, everybody.
Good. All right. James Taylor. Yep. Good night.
Good night, all.
Emma. Yep. Okay. Douglas. Keith Howard. I didn't hear anything from you tonight, but hopefully we'll hear from you next time. Same with John Atwood, Lisa Lou. Yep. All right. Good night.